بسم الله الرحمن الرحيم رب زدني علما.
Now let's move to the configuration part here. So what I'll be doing is we'll try to get into the configuration. The configuration is pretty simple and straightforward. Okay. So what we have to do is, like in this example, like the configuration is we need to go and say which protocol you want to run. So we have the command called router RIP. So I simply go and say router RIP, router RIP, router RIP. So like that you have a router. If you use question mark, you will have router OSPF, router EHRP, router BGP. Like that, you can choose any protocol, whichever the protocol you want to enable. Okay, so we have to enable the protocol, and then we need to simply advertise the network IDs. Now, what this means is I need to go to router 1. If I just come to the configuration, so the first command is router RIP, and then we need to simply advertise my own networks. So, which means on the router 1, I need to advertise my own network, that is 10.network, and I have to advertise my own network called 192.168.1.network. So if you remember what we discussed in the dynamic routing is it works through advertisements. So where we have to advertise our own networks. I don't need to bother about the destination network ID. I don't need to know. I don't need to bother about the next hop, not compulsory. I don't need to know. And I don't need to bother about any other network. So only thing what we do is every router will be advertising their own networks, and they will exchange and they will automatically build the routing table. Okay. Now, similar way, go to router 2 and simply advertise three networks, that is 10.network, 11.network. Network IDs we have to give. Of course, these all network IDs. Okay. Don't give the IP address. You have to give the specific network ID, the entire network we are advertising. So if I don't give the version 2, then it will be version 1. Okay. If I don't give this version 2. So you always use version 2. And remember, version 1 and version 2 are not going to exchange the routes. So if you mismatch, if you see one side the route exchange happens, probably the version mismatch. So remember that. Now, similar way on the router 3, we have to advertise our own networks, that is 192.168.3.network and 192.168.11.network and 3.network. So the easiest part in the dynamic routing is the configuration, and you do just once. And that's it. There's no need to bother about. Unlike if you see dynamic routing, it's very difficult. You must know the destination, you must know the next hop, you must know how to reach that particular destination, all the information you have to manually give. And already we covered those points in the theory. So now you can clearly see those points here. It's very easy. So let's jump into the configuration. So what I'll do is I'll quickly open up one topology where I'll try to use a topology with multiple routes. Okay, that's something I'll try to do. 3 routers topology, redundant links. I'll try to use this. Okay. So as you can see, I'm using redundant paths. So this is already pre-configured. A slightly different topology. Okay, so we already have this topology here. You can just take this topology. And the only difference is we also have one more connection going from R1 to R3, which is typically using 12 dot subnet, like 12.1 here, 12.2 here, and there are 2 connections. So this is just to verify the dynamic routing, okay? And I assume this IP addressing is already done. So the prerequisite for this is we have to make sure that we already have the routers pre-configured with the IP addresses. So we'll quickly verify that. When I say show IP interface brief, you can clearly see when I say show IP interface brief, the router 1 is enabled with this IP 10 and 12. The other interface is S0 by 0 by 1. Okay, this is S0 by 0 by 1, and this is S0 by 0 by 0. So the router 1 is configured already with the IPs. Let me check if the routing is already there. Now we don't have the routing. So luckily we don't have the routing. So which means I decided to use dynamic routing RIP. So if there is any other routing, you can verify that by using a command called show IP protocols. So if there is any routing, you will see the routing will be enabled here. As of now, we don't have any other dynamic routing protocols enabled. So let's go back to the router 2. on the router 2 also, what we'll do is we'll go ahead and verify the router 2 part. So this is my router 2. Now on the router 2, we have 3 interfaces. So make sure that these 3 interfaces are enabled, like 192.168.2.network and 10 and 11, 10 going to the router 1 and 11 going to the router 3. Now same way we go to the router, the third router. So we'll go to the router 3 and quickly do the verification on the router 3 as well. So this is my router 3. And if I quickly give the command called show IP interface brief, you can see the router 3 is enabled 3.network in the LAN and 11 and 12. 11 and 12. This is 12 S0 by 0 by 1, which is 12.002, and this is 12.001. Okay. So we got redundant connections, multiple connections. I enabled that because I want to verify the dynamic process. Without this also you can enable with a simple 3 routers as well. Simple 3 routers you can do it. It's very easy. So I'm going to show you this one. Now, what I had to do, advertisement. So I don't need to bother about any other networks. I need to simply focus on my own networks. So I need to simply see my diagram or use the command, tell the protocol. And you can see here, I can use any protocol. Like if you say router RIP, there are different protocol options we have. So at this point, we will be enabling the router RIP, telling my router that, hello router, please use the RIP routing and the RIP process to calculate the best routes. And then I'm going to say version 2. Version 2, I recommend you to add before, because normally most of the time we forget that command. So keep it first, but you can write anywhere. 10.network and what is the other network? 12.network, right? 10 and 12. So I need to only advertise my own, not 10 and 12. Yeah, 12. It's not 11, it's 12 actually. I think it's 12 only. 12 here. Okay, that's it. And the same way, we need to go to the router 2 and do the same thing. On the router 2, router RIP version 2, network 192.168.2.network and 10.network and 11.network. Sorry, not 1, it's 11. Anytime you want to remove any network, you can simply add no before that, because by mistake I typed 1, but it's not 1, it's 11. Now let's move to the router 3. So as you can see, the most easiest part here is the configuration. And you just do it once, that's it. This runs for many years, okay? Most of the time you don't disturb the network. The 10.3.network in the LAN, 11.network in the WAN, and 12.network in the WAN. So now let's verify. Give some time for the convergence because the RIP is slightly a slow protocol, if you remember the timers. And of course, in packet tracer, it will be very fast, so it won't be much delayed because of the simulation. So when I say show IP route, you can see the plenty of routes. Let's be specific, show IP route RIP, and let's verify show IP route RIP here. As per my topology, we'll try to confirm and do some quick verifications here. So the first command will use show IP route RIP. You can see here one by one, if you try to see to reach 192.168.2.network or 3.network. So this is my 2.network, this is my 3.network. And to reach these networks, I'm learning this route through RIP. This is specifically saying that I learned this information through RIP. And here you can see there are 2 values. 120. This first value represents the administrative distance, the trustworthiness, and this represents the hops, the metric. So these values will change when you're using different protocols. So as of now, you can see to reach 192.168.2.network, you can go from here. This is 1 hop. You can go from the other way. This is 2 hops. So it's saying that to reach 2.network, you can go via 10.002. This is the next hop. And to reach 3.network, you can go via 12.002. This is 1 hop. Okay. So if you see here, to reach here, there are 2 hops here, and there is 1 hop here. Okay. So it is using 1 hop. So if you see, the next hops are different to reach 2.network or 3.network. And in the basic lab, if you don't add this link, then you will see 2 hops here. Generally, this hops will change. Don't worry, we'll shut down the link and we'll verify the other way. And likewise, we'll also see to reach a 11 dot network. Now, this is the 11 dot network from the router 1. And you can go from here. This is one hop. And you can also go from here. This is also one hop. Now, whenever you have equal paths, it will install both the routes in the routing table. You can see both are installed in the routing table and it is doing load balancing. Okay. So basically it is doing load balancing for both the routes. That I think you can trace to 11.002. Generally, depending upon where you want to go, it uses any one. Like 11 dot network, if you're trying to reach to 2, it goes from there. If we try to go from 1, it will go from here. So this is basically the trace, or mainly whenever you see two entries in the routing table with different next hops, and you can see I did not give the next hop. So the next hop is automatically defined. The exit interface is automatically selected. The metric is also automatically decided. Entries are automatically added. So one of the main command we use show IP route or show IP route RIP or show IP route EHRP. The other command we can use show IP protocols. Whenever we are running dynamic routings, you use one more command called show IP protocols, which will show you what protocol you are running, and you can see the updates. If you remember, we spoke about the different updates, like for every 30 seconds, the next update is supposed to come in 25 seconds. And you can see these interfaces are sending and receiving version 2, and these are the networks what we have advertised, and these are the gateways. Gateways means the next routers. Administrative distance is 120. Okay, so mostly these are the only two specific commands we use for verification. Of course, the LAN to LAN you can ping. That's not a big deal. So if you configure the correct IP addresses, like I'll go to one of my computer and we'll try to verify the tracer to 192.168.3.1. It will show you that it goes to 1.100 and 12.2. 12.2 is the blue line which I have used the connection and reaches the 3.1. So you can see here, and again, if you trace to 2.1, it will show you the output. Now, ping, trace are the basic commands now. That automatically works because these things already we have verified in the static routing, so you can just repeat the same. So we need to do some additional verifications like the routing table. That's what we verified. Now, what we'll do is we'll try to shut down any one link. Like I'll shut down this link, okay? This one. Let me shut down this one, S0 by 0. Any link you can shut down. Let's keep this one, okay? So we'll go to the router 1. Either you shut down the link or remove the link. Both are same. I prefer shut down because that is much easier than removing and adding. Assuming that the link goes down or the router goes down or anything it can be. So we'll try to shut down this link called interface S0 by 0 by 0. Shut down the link. Assuming that the link goes down. So what we should see, we have to wait for some time so you don't get the exact things immediately. So because now you can see whenever you shut down the link, automatically the 2 dot network has been removed. Before there was a 2 dot network, it has been removed. So it is immediately going to the flush, and it is now you can see the link is added. So timers don't follow that here in the packet tracer. Basically, that's not going to be the exact timers shown here because it's just a simulation tool, so you don't expect the exact timers. But as you can see, once you shut down this link, there is no more 10 dot network. Now to reach 2 dot network, I'm going from here like this, 12.2. And if you go to the router, any PC, like previously to reach 2 dot network, I was going through 10.2. If I try to repeat the same command once again, you can see this time it is not using 10.2. It is going via 12 and 11. That is to 3. First, it is going to 3, router 1, router 3, router 2, and then to here. Okay, so the convergence, like I discussed, automatically. But in the case of static routing, if this link goes down manually, you have to change the route. That is something going to be very, very difficult. Okay. So the overall end result remains the same. Whatever the protocol you're running, whether you're running a dynamic routing with EHRP or OSPF or RIP. But I generally prefer the RIP to discuss initially because The main advantage is more easier. You don't need to really worry about many things. But when you talk about OSPF, we'll see more options. We'll spend 2 days or 3 days on OSPF, the basic OSPF at the CCNA level. Okay. So this is something, the verifications are the same: ping, verifications, trace, and verifying the routing tables.